So we have this question that says the area of parallel side, I mean a trapezium of parallel sides 10 cm and 21 cm and height 8 cm is inscribed in a circle of radius 7 cm. So calculate the area of the region not covered by the trapezium. Can you all hear me?
Yes, sir.
Yes, sir.
Good. So I tried to draw a trapezium in a circle to inscribe it in a circle. Then I labeled it as given 10 cm and 21 cm for the parallel side, then 7 cm for the radius of the circle. So to find the area not covered by the trapezium will be to find this green region, okay? So is that clear?
Yes,
So
sir.
Yes,
to do
sir.
that means you find the total area of the circle, then you remove the area of the trapezium from it. And area of a circle is pi r squared. So this is going to be pi r squared minus area of a trapezium, which is half into a plus b h. So pi is 22 over 7 times 7 times 7, then half into 10 plus 21 times the height is 8. So I have 8 cm here. So this is going to be times 8. Then please, are you concentrating? Are you listening?
Nonsense.
Somebody is busy making noise there. Somebody is busy talking. So this is 2 year 1, 2 year 4. Then 7 divides 7 here. Then what is 22 times 7?
One
What?
five four.
154. So we have 154 minus. What is 10 plus 21?
21.
41 times 4.
Eh?
41.
31. 124.
Okay,
124.
31 times 4. That's 124.
That's why it's 30.
124. So this will be 30, right?
Yes,
So what is the unit?
sir. Centimeter. Area of what? Centimeter square. Area of division not more by
Yeah,
15.
that is cm square. Okay. So that is that about this first one. Um, all of you should try this second one, and just in 3 minutes you provide your answer. Okay. Let's let's look at it together. Okay.
That's 60.
Hello, are you listening? So um, the first thing you need to take note of is that angles in alternate segments are equal. Okay. What did I say? Can you hear me?
Yes, sir.
Angles in alternate segments are equal. So the angle in alternate segment are the angle at N and R. So that means angle at R is 64. And you've been given that two sides of this are also equal. So if this is 64, you can find this angle and this angle because they are going to be equal. So angle at N and Q there is going to be, let's say, twice of angle Q plus 64 is 180. So 2Q plus 64 equal to 180. So 2Q equal to 180 minus 64. What is 180 minus 64?
152.
52. 152.
No. Yes. One. It's 152.
180 minus 64.
128.
180.
96.
180 minus 60 is 120.
96.
180 minus
One.
60 is 120. So remove 4 from 120. You have 116. Okay. Then angle Q will be 116 over 2, which is 58. Okay. So if the angle is 58, this place is 58, this other place is also 58, then you can say to find x, x plus 58 plus 64 equal to 180. That is
That's
angles
for you. Immediately, immediately you finish, you have
Taye,
higher.
Taye, you are
Sorry,
making
sir.
noise. So
I'm
we
sorry.
now have x equal to 180 minus this 58 plus 64. That will be 180 minus. What is 68 plus 64? 58 plus 64 is what?
120.
122. So 122. So what is our x? What is our x?
58.
58 degrees.
So I didn't put 122, put 22.
Okay. Yeah. So 58 degrees,
Instead
okay?
of 120.
Is that clear?
Yeah. So,
So
yeah.
um, again, what we said, the principle we used is angle in alternate angles. Alternate segments are equal. So this x supposed to be equal to 58, while this 64 supposed to be equal to the r. So that is the principle there. Is that clear?
Yes, sir.
Okay. So I'll give you time to check this next one and get your answer. So right now we want to look at the solution to this question. So that I can have enough space, let me try to reduce this shape. You can still see the shape, right? Can you still see it?
Yes.
Okay, okay, good.
Yes, sir.
So one thing, the principle you need to remember here is that opposite angles of a cyclic quadrilateral quadrilateral adds up, add up to 180 degree. That is, they are supplementary angles. Okay.
Daniel. Daniel.
Who is making noise there? Hmm?
Sir.
They are supplementary angles. Is that clear? Please don't write anything, just look at the screen. You will get your notes to write. Now, are you concentrating?
Yes, sir.
Okay. Opposite angles are supplementary, they add up to 180. So that means this angle must add up with this angle to give me 180, and this must also add up with this to give me 180. So having said that, we can say 2y, that should be 2y minus 30, right? Or is it plus? Let me, because I've cancelled, it's minus, okay. So 2y minus 30 plus x will give me 180 degrees. Then from here I can say 2y plus x equal to What is 180 plus 30? That is 210
200.
degree. This is equation 1. Then the second one, I will say x plus the x plus y is also 180 degrees. So here I have 2x plus y equal 180 degree, and this is equation 2.
2.
So I will now solve the simultaneous equation, okay? So if you have the simultaneous equation, you have the first equation to be 2y plus x equal to 10. The next one is 2x plus y equal 180. So you find okay, I can rearrange them. So I won't write
5
this.
plus 2x.
Can rearrange them. So that this is going to be y plus 2x equal to 180. So to find the LCM is 2, LCM of this one, you know, which is 2. So this is times 1 and this is times 2. Then I have 2y plus x equals to 210. Then this is 2y plus 4x plus 360. So having said that, we have uh, this minus
Equation
this
2
is
minus
gone.
equation 1.
Then the difference here is
3x.
3x. What is 360 minus
170.
minus
150.
210?
150.
So that is 150. So x equal to 150 over 3, which is what? 50 degrees. So if x is 50 degrees, then we can find our y from any of the equations. So we can say 2 into 150 plus y. Wait, I mean 2 into 50, not 150, okay? Can you hear me?
Yes.
180 degrees. So we have y equal to 180 degrees minus 100 degrees, which is
80.
80 degrees. So, but we were not asked to find y, just x, okay? But let's assume in other equation, they can ask you to find the value of 2x plus y or something. So you just need to know the two values before you now know the final answer. Is that clear?
Yes.
That's clear to everybody. Okay. I'll give you some time to check this and look at if you can get your answer to this. All right. So looking at this question, we have the diameter, which is we have the diameter which is AOD, okay?
We are not giving the length of the diameter.
Hold on, hold on. Can you hear me now?
Yes, sir.
Now, looking at this question, we have the diameter AOD and we have the chord BD, the chord here, BD. Since it's the same, and we're looking for angle AOB first. This AOB, this angle, is what we're looking for at first. So since it's this chord that subtends, hello, are you concentrating? Somebody is still talking. So since it is this chord that subtends this angle at the circumference and subtend the same angle at the center, then we have the principle that angle at the center is twice the angle at the circumference. So that means angle BOD will be twice of angle OAB. OAB. That is, the angle at the center is twice of the one at the circumference. Is that clear?
Yes, sir, very good.
So if that one is certain, then BOD, which is this opposite side of where we're looking for, BOD will be 2 times 34, which is 68 degrees. So we can fix 68-degree here. Then we can say 68 plus the AOB gives us 180 degrees. That is angle on a straight line. Then we now say the AOB we're looking for is going to be 180 minus 68 degrees. So 180 minus 68 is what?
122.
1, 2. Are you sure? 122?
No, something 112.
112.
52.
112,
Different
right?
22. Okay. Yeah, 112.
So if this is 112, that will be 112. Good. Then we need to find angle OCB, which is the angle at this place. OCB, considering the triangle OCB. Okay, since we've already known uh, the angle at the center of this, then we can find this angle. If we find this angle, then we can also know this to be 90. Okay, is that clear? So
Yes,
angle,
sir.
angle, let me see, angle ODB will be equal to angle OBD, which is because this is a radius and this is also radius. So these base angles will be equal. So with that, we can find this particular angle. Is that clear?
Yes, sir.
Good. So to find the angle BDC, which is this angle, we're going to take this away from 180, whatever we get here for this ODB. Take it away from 180 to get this one outside. So, and to get ODB, we can have 68. If we name this X and name this X, so we have 68 plus X equal to 180 degrees. So 2X equal to 180 minus 68, which is 112. So X is 112 over 2, which is what? 56 degrees. Okay?
Six, yes.
So if the angle at X is 56, then we can get this angle. We can also get this angle. How can we get these two
Yes.
angles? Is that BC is a tangent, okay? BC is what?
Detergent.
BC is tangent. And the tangent is a line that makes 90 degree with the radius when it touches the circle. So it touch the circle at this spot. Then we know that this total angle is 90. So we can get the one outside, okay? Therefore, we can say angle DBC, angle DBC equal to 90 minus 56. Okay. What is 90 minus 56?
24.
What did you call it?
It's on
34, sir.
Okay, 34. So that angle there is 34 degrees. So we have one of the angles in this triangle already. Then to get this second place, that is with 180. So we can say angle angle BDC BDC equal to 180 minus that 56. Okay. So what is 180 minus 56?
capital coming back.
Okay, what is 180 minus 56?
120.
124. Okay,
70.
Okay.
Short blood.
all right. So we have 124 here, right?
Yes, sir.
Then OCB. OCB is in a triangle with all of those two angles. So that's what we're looking for. Will be 180 minus the 124 and the 34. Is that clear?
Yes, sir.
So OCB now equal to what? 180 minus what is 124 plus 34?
158.
158. So what is 180 minus 158?
22.
22. So that is how to find the angle. Is that clear? Is that clear now?
Yes. Yes,
So
sir.
if you look at how we arrived at all of this, what we did was that we considered the chord BD first. It's obtained angle 34 at the center, at the circumference, and angle 68, which is twice of 34 at the center. With that, we're able to find the counterpart 180, at the middle, which is the first question, okay? Is that clear?
Yes, sir.
Then the next one is to find this angle at C, but we can't jump there without finding some of these other angles. So since this is 68 and this is a radius, BO is a radius, OD is a radius, then this is isosceles triangle. We have the base angle at B and D to be equal. So with that, we're able to get X to be 56, each of those angles. And this is a tangent BC. Are you listening? Are
Yes,
you?
sir.
Yeah, BC is a tangent which makes 90 degree with this radius BO. Then with that, we say 90 minus 30, minus 56 give us 34. Then this is angle on a straight line with x and the other angle inside the triangle. So we are able to remove 56 from 180 to get 124. Then 34 and 124 are already in the triangle BDC. And we are looking for angle OCB, which is this, which is in the triangle BDC. So with that, we're able to find the other angle to be 22. Is that clear?
Yes, sir.
Okay, so I'm going to give you look at this. Look at this one. I'll give you a few seconds to try this particular question. Okay. Right now, want to look at the solution to this. Then we round up for today. Okay. In the diagram above, it's not drawn to scale. A, B, C, D are points on a circle center O. Take note of something. We have been using the principle that has to do with cyclic quadrilateral, right?
Yes, sir.
If I draw a circle here and I put a quadrilateral inside, this way. One, two, three, and four. This is not a cyclic quadrilateral, okay? Not a what?
Cyclic quadrilateral.
Not a cyclic quadrilateral. And why? This is because all the sides of the quadrilateral are not touching the circumference, okay? Only two sides are touching the circumference, but these two other sides are not touching. Are you hearing me? Are you hearing me?
Yes, sir.
Okay. But look at the one we have. Look at the one we have. These four sides are touching the circumference. Yes or no?
Yes, sir.
So that is the difference. So for this one, you cannot use the principle of cyclic quadrilateral. Okay? So if there's any principle that you need to use, it will not be binding. But let us go back to the question that we have. Let's say we're looking for angle BAD. This angle. This is what we're looking for. And we know that this is our diameter. Okay?
Yes, sir.
Because of the center O. Then we know that diameter is going to make um 90 degree here. Okay? Are you hearing me or you are talking?
We're hearing you, sir.
Okay. So if I join this other side,
You know,
then I have
thank you.
90 degree here. So once I have my 90 degrees, I can know this angle to be 40 degree, but that is not the total angle I'm looking for, okay? So this internal angle here is going to be 40 degrees, but that is only part of BAD, not the total of BAD. Then, from the triangle at the top, you can see that triangle at the top, right? Right?
Yes, sir.
This is B,
Yes, sir.
this is A, and this is C. So this is equal to this, meaning that the base angles will also be equal, okay? But we need to find this angle at B. Are you concentrating as we're about to round up? So we need to
Yes,
find this,
sir.
we need to find this angle at B. Now to find the angle at B, we will use this and this. Can you see this? These are opposite angles, okay, of a cyclic quadrilateral. So we can say angle B plus angle D is 180 degrees. So that means angle B will be 180 minus 50 because angle at D is 50. Then that angle at B will be what? 130. So it implies that the angle at the top here is 130. Then we can find these base angles. Which one of them is part of the A? So uh, let us say the angle we're looking for BAD will be A1 plus A2. So we already know A1 equal to 40 degrees. Then let us find A2 here. So to find A2, We can use this as A2 and this also as A2. So A2 plus A2 plus 130 equals to 180 degree. So twice of A2 equals to 180 minus 130 degrees. Then twice of A2 equals to what? 150, equals to 50 degrees, okay?
Yes.
Then what is that angle A2? That will be half of this, which is 25 degrees. So angle BAD now, angle BAD will be what? 40 degrees plus 25 degrees, which is what?
65.
Is that clear to you?
Yes.
And this is where we'll be rounding up for today. But before we round up, I want to quickly show you something.